blockchain we built with Ethereum. So, so yesterday, one person asked what is Geth. Geth is the Ethereum application. So using Geth, we are connecting each miner and the Raspberry Pi also together. We are pairing all this. We are pairing all these nodes. So we have peer-to-peer networks. So this is P2P network. So then using this P2P network, we are transacting, we are sending the token from one miner to the RPi. Then RPi is connected to the relay where it connects the light. So the light is switched on or off based on the token value. Suppose if token is greater than 1, that means if it is greater than 1, if it is equal to 10, then it is switching on the light. If it is 0, then it is switching off the light. So that way, we are using private blockchain for IoT, and we can connect all our lights and fans in our home using the blockchain, and we can control the lights and fans and door or locker or whatever. So we can control through the blockchain. So public blockchain is something like, so already the Bitcoin is one of the public blockchain where you can get the Bitcoin. So you can mine the Bitcoin, and if you get the even one Bitcoin also is several $1,000 you will get. So that is a big business. So you try that public blockchain also. So you need a lot of computation power. So you need a lot of the mining work. Then you will get the cryptocurrency you can get. It's also great if full transparency of the ledger or individual anonymity or desired benefits. Costs are higher and speeds are slower than the private chain, but still faster and less expensive than the accounting systems and methods used today. So this is one example is Bitcoin. You can try this. Even Ethereum also you can try. So Hyperledger, Ripple, and Ethereum are examples. So private blockchain is something different. Private blockchain lets the middleman back in to a certain extent. That means, see, this is for only one purpose, where the here the middleman back in the sense. So one company or one entity can use this private blockchain. For example, you are the smart home solution provider. Then you can make your own private network. So nodes you can connect. For example, in our layout, 44 villas or so, 44 nodes we can create, and then one blockchain we can connect, and then we can control using this. Private blockchain only within the layout we can control. So one layout, one blockchain you can create. So the company writes and verifies each transaction. This allows for much greater efficiency, and transactions on a private blockchain will be completed significantly faster. So, but this transaction will be very faster because public blockchain has millions of nodes, and you need at least 51 percentage approval for any transaction to happen. So that many nodes should approve. So it will be a little bit slower. So you cannot use it for real-time operations. So if you want to use for real-time, for example, you want to use for drone or robo control, then your blockchain has to be private blockchain where the miners will actively approve the transactions within a few seconds. The company can also choose who has read access to the blockchain's transaction, allowing for great privacy than a public blockchain. A private blockchain is appropriate to more traditional business and governance models, but that is not the bad thing. So mainly for our business purpose, we can use private blockchain. So private blockchain, we can have number of mining nodes. For example, if any professor is doing blockchain research, then you can check whether how many mining nodes are required. For example, in our home, maybe around 10 lights are there, then so maybe 10 fans are there. Then doors are one door, one locker. So to operate this many, how many mining nodes are required? For example, if mining nodes two are there, how long it takes to switch each one. If it is 3 are there, how long it takes? 4 are there, how long it takes? So then RAM, the RAM size is 4 GB, how much it takes? 8 GB, how much time it takes? Then 12 GB, how much time it takes? So like that, if you have some experiment, if you contact, and then if you tell the result, like if to operate this many lights and this many fans, we need this many mining nodes, and this the RAM size is this much, and the CPU should be this much. How many CPUs are required? Like that, if you give one experimental result, then it will be more useful for our industry people who can connect these many nodes and with private blockchain. So here some examples are multi-chain, Stream Core, and Microsoft Azure and all examples. So consortium blockchain is partly private. Instead of allowing any person with an internet connection to participate in the verification of transactions process, are allowing only one company to have full control. A few selected nodes are predetermined. So here it is in between these two, private and public. So some people are authorized to operate these transactions. So some of these, the consortium are 42 banks with the combined 600 billion market cap and 60% of global sci-fis. So JP Morgan is also one of the example. No? Now smart contracts. So what do you mean by smart contracts? See, in our case, we have the so we have two mining nodes, miner one, miner two. Then we have one RPI. So then RPI has to, so this has to communicate from this to this and this to this to the all are paired. Now to send the transaction from miner one to RPI, we need one common protocol which will be understood by both the people. Actually, the miner one also should understand, RPI also should understand. In backend, anyway, blockchain is running. The block is, we have the Genesis block. We created the Genesis. The same Genesis block is used here also. Here also. So then the blockchains are, here this miner is keep on adding the blocks, but RPI will not add any block because RPI memory is around 1 GB only. So 1 GB memory. Then it is CPU also very limited speed only. So it cannot do mining work. If we start mining in RPI, it will hang actually. So we cannot do mining work here. Only the mining work is done by only this miner one. So the idea is here is the smart contract is a function. See, we are creating function to deposit, then to withdraw. Two functions we are creating. Then when the deposit function will add the tokens to the RPI. The withdraw function will withdraw the token from the RPI. So that is the way we are constructing a smart contract. The smart contract is nothing but the logic, business logic. It is a business logic. So smart contract means, what is the meaning? It's a business logic. So smart contracts were first proposed by Nick Szabo in 1996. Smart contracts are a way for people all across the globe to do the business with each other, even if they don't speak the same language or use the same currency. So the advantage is smart contract is, since it's a logic, we need not know about the language, Japanese language or Korean language to have the transaction. For example, I want to transact some money to one Japanese guy. I need not know his language. I need only smart contract. Just use the smart contract, withdraw and deposit. Only these two functions sufficient. I can deposit money to his account, or I can withdraw the money from his account. So that is if it is approved by the all, at least 51% of the nodes in the blockchain. So smart contracts are the way for people all across the globe to do the business. So it's not only for transacting money. It's a transaction of, for example, I want to sell a car to a Japanese guy. Then I need only a smart contract like buy and sell. So if I write the function, two function buy and sell, then I can transact with anybody in the world to do the transaction. I need not know their actual natural language. A smart contract is a computer protocol intended to facilitate, verify, or enforce the negotiation or performance of a contract. So it is nothing but the protocol, or you can say it is a business logic. It is a business logic which can facilitate the transactions. The aim of smart contract is to provide security that is superior to traditional contract law and reduce their transaction costs associated with contracting. For example, I want to sell a house, so here one owner is there, here one buyer is there. So I want to sell I want to sell a house. Then I need not go to the registration office where I have to pay at least 10 percentage of the cost. For example, 45 lakhs apartment if I want to buy, then I have to pay at least 4.5 lakhs. I have to pay to the registration office. So that we can avoid. Only we need to give a small money for the miners to approve this transaction. Then I can send this transaction. See, this is the smart. I can publish the smart contract saying that this house is for sale. Then the buyer will take the same smart contract and he will buy. Once the transaction is done, then the 51 percentage of network will approve this. Then the ownership will change from owner to seller, the whatever buyer. So the owner's name will be transferred to the buyer name, and then the house will be registered in the buyer's name. So we can avoid the registration office. So these nodes are, they trust each other, because now because registration office come into picture, because we don't trust each other. For example, if I want to buy a house from another person, I don't trust him, then I will go to registration office, I will register there. Then I believe more registration office more than the neighbor. So here the case is different. My neighbor node I am believing, then I am believing the whole peer-to-peer network, the 51 percentage of node, they know it's a genuine transaction or not, and then they approve the transaction. Once based on their approval, my ownership will change from the owner's name to the buyer's name. So we can reduce the transaction cost here. Smart contracts have been used primarily in association with cryptocurrencies. So it is mainly used for cryptocurrencies, but we can use it for any business. Benefits of smart contracts. So one is autonomy. You are the one making the agreement. There is no need to rely on a broker or lawyer. This is a major government agency not required. Then second one is trust. So your documents are encrypted on a shared ledger. So all your documents are encrypted and then it is stored in the shared ledger. The ledger is in all the nodes. For example, we have 4 nodes. The ledger is in all the nodes, but all are encrypted. Only the owner can understand or the buyer can understand the ledger. So we'll see how it is happening in the next slides. So then backup also there. On the blockchain, your documents are duplicated many times over. Suppose your blockchain has 1 million nodes, then the 1 million copies are stored in the peer-to-peer network. So even hacker hacks one node, even the remaining from the 1 million nodes, you can take the ledger back. So that is the advantage. The backup is there in the 1 million nodes section. So then savings. Smart contracts save your money since they knock out the presence of an intermediary. So it saves a lot of the brokerage you can save. Then accuracy. Smart contracts are not only faster and cheaper, but also avoid the errors that come from manually filling out heaps of forms. So I remember one time when I bought my my apartment. So the document was written. So the document was written. So the previous day they said the soft copy. So I gone through the document. It was okay. Then the day of registration, the broker is more favor to the owner. So what he did, he told, oh, I'm going to take printout. I agreed, okay. Then he took printout also. In the printout, he removed one paragraph. So that paragraph says, I will get a car parking in the in the parking area. In the parking area, I would get 10 into 9 the parking area. 10 feet into 9 the parking area, 15 feet into 9 feet parking area I will get. So So this paragraph is removed. When he took the printout in the morning, he nicely removed this paragraph. Then we are standing in the registration office in the queue. We are standing in the queue. I was reading the document. Then I observed this is missing. This paragraph is missing. I quickly understood this paragraph is missing. Then I told when it come to the registration in front of register, I told I cannot sign because one paragraph is missing. Then the owner wrote manually this paragraph, and then he signed in multiple places. Then we registered. So the accuracy, the manual, when we do lot of manipulation is possible. See, if you don't know to read the document or if you don't remember the paragraphs in the document, anytime anybody that can cheat you, then you will miss one parking. See, parking area today in Bangalore, getting parking area, it is very costly here. So the one fraction of second, I was about to miss the parking area, but luckily I got this parking area because we remember all the paragraph, what and all they have written, and then one paragraph I observed it is it is missing. Then I got back. So the what I'm telling, the accuracy whenever I do manually, lot of manipulation and lot of favoritism. For example, owner is influencing the brokers, and then they are in favor of them. They are writing the document. So the accuracy will come when smart contract is used. Nobody can manipulate this smart contract. We know the smart contract will work in this way only. So smart contract will have the function, this many functions. Only these functions will do this many. Only this many. These functions will have this many. Only this is the functionality it will do. So smart contracts cannot manipulate the people. So if we do manually, the lot of cheating work is there. So for example, in Bangalore, one site is sold out to the 5 different buyers. So nobody aware of this. But in blockchain, this kind of manipulation you cannot do because the ownership, the moment you change the ownership come to the different person, and it will be unique. The record will be unique, and the block is added to the blockchain, and nobody can manipulate the blockchain. Hacker cannot hack this block. So it is highly accurate. It's highly accurate. These blocks are highly accurate. Are not only faster and cheaper, but also avoid the errors. Errors, not only errors, manipulations, and that come from manually filling out heaps of forms. Smart contracts on the blockchain. A smart contract is a computer code with a predefined set of rules. It runs on a blockchain and sets the condition under which all parties to the smart contract agree to the interact with each other. It auto executes if and when all conditions are met. So it's conditions, the functions are defined already. So it runs on the blockchain and set the conditions under which all parties to the smart contract agree to interact. So the smart contract is visible to everyone, and everybody will agree to this smart contract. Then only this smart contract can be executed, and all the 51% of the network will agree this. So and then they have to approve this. So that is the way the smart contract is very, very secure and accurate also. Then paper contract. See, paper contract you see here, Alice agrees to pay 20,000 euro for the car. Once Bob gets the deposit, he will transfer the vehicle ownership to Alice by handing her over car documents and car keys. So this is the paper contract. In front of the lawyer, they will sign and they will give the money, then they will take the ownership. So, but in blockchain, what will happen? So in blockchain, how it is happening? We'll see now. So here Bob wants to sell the car, then Alice wants to buy a car. Now they will go for a paper contract. A trusted third party is in front of lawyer, or they have to go to the registration office or notary public, and then they have to sign the notary public. So a trusted third party is required for verification. In order to officially transfer the ownership to the car, the terms of the contract have to be met. I'll try the zoom function. So if for mobile users, maybe the zoom function may be helpful. A trusted third party is required for verification in order to officially transfer the ownership of the car, the terms of the contract have to be met. The process differs from country to country, but always involves one or more trusted third parties. Motor Vehicle Registration Authority in combination with a notary and a insurance company. So three authorities are required. One is RTO office required, then notary public lawyer is required, one insurance company to change the insurance, the ownership, that also required. It's a complicated and lengthy process. Middleman fees apply. So here one middleman fees is a lawyer you have to pay. So then insurance will give different conditions. Then you have to pay a lot of money to RTO also. Without paying money, you will not get anything in RTO. Then smart contracts. Now you see how smart contract works. In case one, what happens? Smart contract is defined here. If 20,000 euro, so I'll just make the zoom function. If 20,000 euro were sent to my account number 757382, then automatically transfer car ID 13849Z as well as grant smart lock access to the account from which the money has been transferred. So the idea is, so the first the buyer has to send the money 20,000 euro, then the account to this particular account, then the smart contract is written in such a way. Once this money is received, the car ID as well as the smart lock access. So the ownership of this car will be changed to the buyer, and then there is a smart lock where the keys are kept inside the smart lock. The pin, the OTP for this lock will be given to the person who is paying this 20,000 euro. So this is the way the smart contract is written. So now you see what is happening. So Bob wants to sell this car. He wants to buy this car. To define the terms of the sale, signing it with his private key. So now he is signing it with a private key, and then he is sending the smart contract. At the same time, Alice wants to buy a car. She finds Bob's car listed on the internet. She signs the contract with her. She signs her contract with her private key, transferring 20,000 euro from her blockchain address and then 389157 to Bob's blockchain address, the 757382. So two addresses are there. One is from address 389157. Two address is 757382. Now she transfers the money 20,000 euro. Now what is happening? Bob leaves his car and car key in a garage locked with a smart contract controlled smart lock. So like IoT device, this is also IoT device. So once the smart contract executes and then the money is transferred, then there is a embedded system which will accept the OTP pin associated with the lock, and then lock can be opened. So Bob leaves his car and the car key in a garage locked with a smart contract, controlled smart lock. The car has its own blockchain address, public key. So 13849Z is stored on the blockchain. Now with the public key, it is stored. Now you see the third step. So here, this is the third step. Alice wants to buy a car. Okay, then fourth step. The smart contract is verified by each node on the blockchain network. The smart contract is verified by each node on the blockchain network, checking if Bob is the owner of the car and if Alice has enough money to pay Bob. So now the smart contract verifies that whether Alice has money, Bob is the owner, all checks it is doing. So there is no middleman to check all this. So the smart contract checks all this. Then if the network agrees, now 51% should agree that all conditions are true, Alice automatically gets the access code to the smart garage lock. The blockchain registers Alice as the new owner of the car, Bob has 20,000 euro more in his account and Alice 20,000 euro less in the account. So the money is actually transferred and the lock key is transferred to the Alice, and then she gets access to the smart garage lock also. So everything happens automatically. Now, what is the next step? Alice can now pick up her car by unlocking the smart lock with her press. So she can go to the garage and unlock with the OTP. Then she can take the key from the garage, the lock, the smart lock, and then she can drive the car to her home. So these are all happening without seeing the face itself. See, the Bob and Alice, they never seen each other, but it is happening automatically. So that is the way the blockchain works. Why can I trust the code? So see now, there is a thief called C. The C steals the car and claims ownership of Alice's car. Since every transaction is stored on the public blockchain, everyone can inspect it and see that the owner of the unique. So everyone can inspect it and see that the owner of the unique car ID with the blockchain address 13849Z is Alice, not C. So now a thief is claiming, so I am the owner, but the blockchain rejects this actively. So this block cannot be added by the C. The hacker cannot inject a block in the blockchain saying that I am the owner, like that he cannot inject. So the blockchain will reject because 51% of people, they know Alice is the owner and they will actively reject this transaction since the thief not transferred any money or any transaction not done. The blockchain will reject this transaction, and he cannot claim I'm the owner for this car. So anyone can inspect in the blockchain. They can see the blocks added. So any point of time, like they can see he is the owner of the car. So the complete history of the car will be in the blockchain. So the blockchain will have, it's a database basically. So it will have who is the manufacturer of the car, what is the name of the car, and what is the so which year model, and who is the owner of the car, what is the insurance paid, what all the information will be in the blockchain. So anybody can see at any point of time. The transparency of data is there. So it is visible to the complete network. So network also know Alice wants the car. So they will actively reject this block. Use cases. So now supply chain management, e-government governance, then gaming and gambling, bank and insurance, energy sector, IoT, creative industry, IT service industry, legal technology, mobility, accounting, auditing, digital identity. Many use cases are there. So now we can start many mini projects. So you can see this. Many nowadays mini projects are no part of the curriculum. For example, in Dayananda Sagar University, mini projects there is 15 marks you will get for mini projects. So mini project you can do with this kind of technology. You can fusion and you can do. For example, IoT plus blockchain. So then Web 3.0, then cloud computing. So we need not stop here. We can extend this mini project. We can add AI also. For example, one use case I'll tell. So in your home there is a lock. There is a locker. So but the locker can be opened by manually open. But now we are going to make it smart locker. So for smart locker, the face recognition technology in the Android phone. So Android you can add in this face recognition. So once face is recognized, so AI plus Android. If you have Android application with the AI where face recognition is added, then data science. So you need data science also. Then if you combine these three technology, then you can implement one smart locker along with this blockchain. So now your smart home will have the blockchain, then IoT, blockchain, Web 3.0, cloud computing, AI, then Android and data science. So 7 technology you can use to make a mini project, and then you can use it in your home. Smart contract, which language should I learn? Ethereum. So Ethereum is using Solidity language. So we'll see some Solidity language. I saw yesterday. I showed you the using the remix we built one Solidity example. Solidity is a statically typed programming language designed for developing smart contracts that run on the EVM virtual machine. Solidity is compiled to bytecode that is executable on a virtual machine. Developers are able to write applications that implement self-enforcing business logic. So it's basically a business logic. Smart contract is nothing but a business logic embodied in a smart contract, leaving a non-repeatable and authoritative record of transactions. Writing smart contracts in smart contract specific language such as Solidity is referred to as easy than even though they don't have the programming skills. So this is one example, the contract token. So the name is token actually. So here, so I'll just zoom in. For mobile users, I think it is visible now. So mapping, first we are mapping the address. It's an unsigned int. So public coin balance of. That means this is the main balance, coin balance. Then there is a event always emitted from the each transaction. So this event will be sent through the blockchain and Web 3.0. So Web 3.0 will listen to this and then it will transfer this event. So coin transfer. So what and all it will be there in the message. In the message address, sender address, receiver address, and the amount how much he transferred. These three information will be there in this message. So it's a message basically. So even the message will be sent in the blockchain with the three things. One is address, sender address, then receiver address, and the amount. So this function is a token. So this is it is nothing but the constructor. You can see the constructor. See, if you know the object-oriented programming, so you may be knowing about constructor also. So constructor is the one when you create the smart contract first time. So if the instance will create whenever the first time when the instance is created, that time it will initialize these variables like the uint supplies the input variable, which is initially if it is 0, then the supply is loaded with 10,000. So coin balance of message sender is this will be assigned here. The supply, whatever the value we are loading here, that 10,000 or some value will be assigned to coin balance of message. It's an array basically. So the center address, the coin balance with the center address will be loaded with this value supply. Now the function send coin. The function send coin, what and all it is taking the argument is one is the receiver address and then amount. So the sender address already there here defined. So sender address already defined here, whereas the receiver address is it has to be mentioned each time. So here you see, for example, minor 1 is sending to the minor 2. Minor 1 is the sender, and then minor 2 is the receiver. Then you can see here the address receiver and amount also. Then returns it is Boolean sufficient. If coin balance of message sender is less than having amount, the amount specified, suppose you don't have sufficient fund in your account, then it will return false. Then if you have the enough fund, then the sender address, the sender account will be reduced by this amount. For example, sender is sending 1,000 rupees. So in his account already 10,000 rupees are there. Then 10,000 minus 1,000, 9,000 only he will be having. Whereas the receiver account will be added this amount. This 1,000 rupees will be added to the receiver account. Then the coin transfer, message sender and receiver and amount. This is the even now it is sender and receiver and amount. This event will be emitted by this function. So this is your smart contract. This is what defining your business logic. So the business logic is defined by the smart contract. So what is a hash? The values written by a hash function are called hash values, hash codes, digests, or simply hashes. The hash function is used to index the original value or key and then used later each time the data associated with the value or key is to be retrieved. Hashing is always one-way operation. There is no need to reverse engineer the hash function by analyzing the hash values. So hashing is the one, it is in blockchain, it is automatically done. When some data is given, it is converting to this is what the crypto operation happening here is, it is converting to the different value, like hash function is used to index the original value of key and then used later each time the data associated with the value or key is to be retrieved. So the hash function will have the key value pair and then the key will, whenever you send the key value, it will retrieve the value for this particular key. So some of the hash functions are MD5, so message digest file. It is widely used hash function producing a 128-bit hash value. So the whatever data you are sending, it will be converted to 128-bit hash value. So you will use this hash function to convert this. This is encryption. So this will call it as encryption. So this is encryption activity. Although MD5 was initially designed to be used as a cryptographic hash function, it has been found to suffer from extensive vulnerabilities. Even the hackers can hack this value. So now SHA-3256 has come, that is Secure Hash Algorithm 3, the latest member of Secure Hash Algorithm family of standards released by NIST on August 5, 2015, is a 256-bit hash value. Then KECOC 256, it is based on a novel approach called spongy construction. Spongy construction is based on a wide random function or random permutation and allows inputting, absorbing in sponge terminology and amount of data and outputting, squeezing any amount of data while acting as a pseudo random function with regard to all previous inputs. This leads to great flexibility. So these are all the different hash functions used in the blockchain. Now cryptography. Symmetric cryptography. John has a box with a lock. As usual, the lock has a key that can lock and unlock the box. So we know, okay, we have a locker. We can open and unlock with a key. If John wants to protect something, he puts it in the box and locks it. Obviously, only he or someone else with a copy of this key can open the box. So we need this key to open the box. That is symmetric cryptography. You have one key and you use it to encrypt, lock, and decrypt, unlock your data. So you are using two options. One is lock and unlock. Now asymmetric public key cryptography. So here the concept is different. Here A is locking and C can also lock it and B can unlock. So this is asymmetric public key cryptography. How it is happening? John has a box. It's a box with a very special lock. So A is locking, C is locking, and B is unlocking. You can see this look as three states. A is locked, B is unlocked, and C is unlocked. So we have three states here. The A is a locked state, C also locked state, B is unlocking state. And it has two separate two keys actually. So see, so far we have seen one locker has only one key, but here it has two keys. How two keys? First one can only turn clockwise from A to B to C. Second one can only turn counterclockwise from C to B and A. So two keys are there. So it is unidirectional. You cannot make it in bidirectional. Either it will go this direction or this direction. Public and private key. See, this is what the cryptography would understand in blockchain. So here, Alice and Bob both are there. So they have the plain text here. So the agreement. Now Alice has private key and Bob also having private key. Now The Alice is encrypting the whatever the digital document with encrypting with Alice's private key. Then the encryptor is done now. Now you see here the ciphertext is converted to the encrypted form and then it reaches the other end. So in between now, a hacker is trying to see what is going here, but the hacker cannot decrypt and see the data because the data is encrypted with Alice's private key and then Bob's public key. You can see here the encryption happens with two keys. One is Alice's private key and Bob's public key. So these two are no these two are used for encrypting. So now what is the advantage here is Alice need not share the private key to anybody, but Alice can share the public key to all the people. So now Alice public key is available with Bob also. Bob's public key is available with Alice also. So that is why Bob's public key Alice is using, and then she is encrypting with the document, encrypting the document with both Alice's private key and Bob's public key, and sending through the internet. In the internet, hackers always alert and they are watching what is going on in the internet, and they cannot decrypt without the Alice's you can see how decrypt what and all can happen. See here, since Bob's public key is involved here, so Bob's private key is required to unlock this. So now to decrypt this document, so Bob's private key is required to decrypt this because she used Bob's public key to encrypt. So Bob's private key is required to decrypt or unlock. This is missing with the hacker. Hacker don't have the Bob's private key, so the hacker cannot see the document. What is the content of the document in the internet? So even though hacker can take the document, it's not useful for him because the document he or she cannot open the document and see the data here. That is the biggest problem hacker is facing now. Now you see the decrypt again happening with Bob's private key, and then one more decrypt digital signature with Alice's public key. So here Bob's private key is the first one required to decrypt. Then that to read the document again there is a digital signature involved with Alice's private key. So that can be unlocked with Alice's public key. Then that plain text format to see Bob can read. So this is the mechanism used in the public and private key where the all our cryptography is working in this way. So the cryptography works with the public and private key of each individual user. So suppose if you want to send for one particular person, you would use their public key and then lock and then send the document. Then only that person can unlock and see the document. So even though internet is very weak and anybody can see the document in the internet, but they cannot open and read the document. Just they can keep the document with them, but there is no use for them unless until they have the particular private key who is involving in this, who is the intended person. So here, now you see the signing happens, then here the encrypting also happens. So here you can see sender has and the recipient has. Sender has the private key of the sender's private key, then recipient's public key. Whereas recipient has sender's public key and the recipient's private key. So in this case, sender and recipient, they should not share their private key at any point of time because private key is very critical. It should not be shared at any point of time. This is very important in the cryptography. So double spending problem. So in the blockchain, there was a problem called double spending problem. It's a problem unique to digital currency because digital information can be reproduced relatively easily, so that the same data can be replicated. Physical currencies do not have this issue because they cannot be easily replicated. And the parties involved in a transaction can immediately verify the bona fides of the physical currency. With the digital currency, there is a risk that the holder could make a copy of the digital token and send it to the merchant or another party while retaining the original. So original you can retain and send the duplicate copy of this digital currency. This was a certain concern initially with Bitcoin, the most popular digital cryptocurrency. Since it is a decentralized currency with no central agency to verify that it is spent only once. However, Bitcoin now they added a mechanism based on the transaction logs to verify the authenticity of each transaction and prevent double counting. So double spending problem now they are removing from the system. Double spend problem is, for example, buyer is no the he is getting here seller A also, seller B also. They are duplicated actually. Mining. So mining is very, very important. We have to understand what is mining. Mining in the Bitcoin. So we have some exercise. We will do the mining, how it is happening. The process of adding and verifying new transaction records to the Bitcoin blockchain distributed public ledger, which includes all past transactions. During this process, new bitcoins are released from the remaining unmined pool of 21 million total bitcoins. So totally there are 21 million bitcoins are there. So the miners are trying to get the bitcoin from the 21 million bitcoin. So there are two ways to get the bitcoin. One is, see, so many millions of notes are there. You can buy from another person. That is also possible. But if you mine it, then you will get some bitcoins. So 21 million total bitcoins. So this is the total economy of bitcoin, 21 million, but all are not mined so far. So if you put the effort and mining, if you make a large mining farm, and then if you try that to mine some bitcoin, you will be become millionaire or billionaire very short of in very short time bomb period, because the all 21 million are not at released. So during this process, new Bitcoin are released from the remaining unmined pool of 21 million total Bitcoins. The process of adding and verifying new transaction records to the Bitcoin blockchain distributed public ledger, which includes all the past transactions. Mining is a computationally intensive work that requires a lot of processing power and time. So that is one problem here is it requires a lot of processing power and a lot of electricity is required. Mining is the act of participating in a given peer distributed cryptocurrency network in consensus. The miner is subsequently rewarded for providing solutions to challenging math problems. So, for example, here in the network, so the one transaction is happening, then they will give the scientific problem to solve. Then all miners will try to solve this problem, and whoever first solving this problem, they will get some transaction fee for this transaction. Then 51 percentage of miners will approve, then this transaction will happen. So to encourage the miners to do the mining work and approve the some transaction fee, you have to always add in the transaction. And if the transaction fee is attracting, then many miners will compete with each other to approve this transaction. It is done by putting the computer's hardware to use with the mining applications. Nowadays they are using ASICs. So you might have heard about ASIC, application specific ICs. So it will do only mining work. So they are Taiwan people are expert in the hardware. They are making ASICs for this mining work, and then the dedicatedly these ASICs will do the mining work, and it will try to get the transaction fee. So for each transaction in the cryptocurrency network, you will get the money for each transaction. And if you find new block or new Bitcoin, you will get a lot of money for this for each coin. So this is the ASICs what Taiwan people are using. So here you can see the ASICs are connected. The wiring is done. You can see here. It's like bathroom in our house actually. So it's like no, they are using just like that. They are using for mining work. Mining is one innovation that makes a decentralized record keeping possible. The blocks must be analyzed as fast as possible to ensure a smooth running of transactions on the platform. However, the issues of such currencies do not have the processing capabilities to handle this alone. Where miners come in actually. So who is miner? A miner is an investor that devotes time and computer space and energy to sorting through the blocks. So they will always check any transaction is happening or not, and always they check because the problem they will try to solve, and then the mathematical problem they will try to for associated with every nonce, they will try to solve the mathematical problem, and then they will again they will try to get the transaction fee for every transaction. When the mining process hits the right hash, they will submit the solution to the issuer, and then after verification, the issuer of the currency offers rewards, which are portions of the transaction they helped in verifying. So they will get the rewards also for each transaction. They are also offer digital coins in exchange for the work of miners. Sometimes the offer may be a digital coin or Bitcoin. So if you get Bitcoin, so it is almost 30,000 times it appreciated. So you will become millionaire or billionaire in very short period of time. So how does it work? So here more miners join network. So then block creation rate increases. For example, so yesterday we saw the demo, two miners are there, miner 1, miner 2, so then RPi, 3 are there. So in the network, so then if more and more miners are there, the transaction will be very fast, because if one miner is busy, another miner will approve the transaction. And see, yesterday we saw it takes 5 seconds to 10 seconds to switch on the light or switch off. Sometimes we observed 3 seconds also, it is switching off. But this is very random because miner takes its own time to approve. But if you have more miner, then the transaction will be approved very fast, and the lights can be switched on and switched off very fastly. So average mining time decreases here. So then if more miners are added, average mining time decreases. The ideal average mining time is stabilized is 10 minutes per block. That is Bitcoin. In Bitcoin, the approval will happen within 10 minutes. Mining difficulty increases. Now what we can do is, do you remember in the Genesis block, we have the difficulty. The difficulty is 420, which we fixed. I showed you 420 for the Genesis in the Genesis block. So you can increase this difficulty level. Then what will happen? Even though more miners are there, then the block generation rate, it goes down. Once you increase the block difficulty level, then block generation level, block creation rate can go down. Then average mining time goes back to normal. Again, more miners are joining. Again, this is a cycle actually. So in our embedded systems, what we can do, we have to do the blockchain researchers. They have to see if miners are 2, miners are 3, miners are 4, then how much time it takes to get the transaction. For example, it is 5 seconds or 4 seconds or 3 seconds, like that. They have to make a experiment. The blockchain researchers in our group or in our professors who are in the group do this do this kind of experiment, and then you can submit a paper. When you submit the paper, you can involve me also. You can add my name also, and I can also give some write-ups, or I can participate in the experiment also, so that you can add my name also and publish a research paper in the SCI or no, the Scopus. So that kind of some high-end paper we can publish. So think about this. We can make some research papers on this. So this is very important for IoT, and the to switch on the light and fan. Now IoT is starting. So before that, my internet is back. That is what my kid told. So I check, and then maybe we have to break for 10 minutes, and then we will around 11:15 we will assemble. So instead of 12 o'clock, I will complete by 12:10 in that case. So I will show the demo in the real, I want to show something in the Raspberry Pi also. So my Raspberry Pi setup is in the other room. So my internet is back. So we'll break for 10 minutes now. Madam, we'll break for 10 minutes now, madam. Hello? Hello, madam? Madam? Hello? Madam, is there or not? Bala, sir? Okay. Yeah, guys saying, okay, sir. Okay. Okay, then I will I will connect in the other room and then I will make the setup one and then I'll call you back one more time. I'll just log out now. So we have 4-layer model in the IoT. So here information, we'll start with the application. This is application layer. So this is the application layer where, for example, in our case, RPi has the application. So it is a JavaScript based application. Then information processing, there is a management layer. So the management layer is basically, in our case, the Raspberry Pi and then both combined, so then one more layer is a transmission layer. Here blockchain is we are transferring through blockchain and Web 3.0. Then information generation like sensor and identification layer. So in our case, the sensor, there is no we are using command line to execute the on off. Usually sensor will be there. So in the general IoT layer, so here we have integrated application like smart logistics, smart grid, green building, smart transport, then environmental monitor, many things are there. Then information processing like data centers are there, search engine is there, smart decision, information security, data mining. So these are all the information processing. Then network construction is like with wide WPAN, then the WAN also there, worldwide. Then it is a the WLAN also there, WMAN also there. So these are all the different networks we are using. Then the sensor layer, if you see, this is a GPS and then smart device, then RFID, sensors and different sensors are there. So we'll see the layer by layer. We'll explain now. So first we'll start with IoT protocols. So IoT protocol mainly we are using MQTT. That is the message queuing telemetry transport. So here MQTT protocol we are using for IoT. So here various physical layers are there. For example, in the ISO layers are there. The 7 layers you might be remembering. ISO OSI layer. So it starts with the physical layer or the physical data link layer, network layer, then transport layer, then session layer, presentation layer, and application layer. So these 7 layers are there. So here we are seeing the physical layer like Wi-Fi, WiMAX, and BLE, NFC, LTE. See, Wi-Fi we are using every day. WiMAX is something used in the in the smart city. Then BLE is the low energy, Bluetooth. NFC near field communication, then LTE long term evaluation. These kind of the LTE is the 4G. So then NFC also we are using. Then these are all the various physical layer protocols. So you can see here the physical layer protocols is in the physical layer. Then data link layer where radio transmission MAC layer, then adaptation layer. So these are all the things we are radio transmission is the one kind of for example Wi-Fi and all, it uses the radio transmission the radio signals. Then what is DTLS? DTLS is the datagram transport layer security. Then MQTT is message queuing telemetry transport. Then RFC is request for comments. Then COAP is constrained application protocol. Then UDP is user datagram protocol. Apart from this, TCP also we are using. So here you see various A6 LO functions. IPv6 over FOOP adaptation layer using the technology like RFC. These are all the things taking care of this 6 LO. Then constrained application protocol. This is a COAP. COAP also one of the important protocol what we are using. Then constraint security protocol also like DTL, the dice and draft IETF dice profile also we are using. So these are all protocols mainly we are using. So coming back to this 7 layer. So here we are using IPv4 is no the Internet 4 and Internet 6 also we are using. Then UDP. So UDP is mostly used in the case of even in our minor. So minor 1, minor 2, ARPA is there. So minor 1 and minor 2, we are enabling both the TCP and UDP. When we come to the setup of GCP setup, I will explain this. TCP, UDP, how to open your port, both in TCP and UDP, how to open in the GCP. There is something called a firewall. In the firewall, we have to open these two DCP and UDP. You have to ports open. You have to open both the ports in the firewall of GCP virtual machines. That I will explain when it comes when we talk about that. Then system layer also there. Then finally application layer is there. So these are all the control functions, and this is the application. This is the overall how the IoT is working. Then, so some sensors also there, the dust sensor or COTS, that is commercially off the shelf dust sensors. So different dust sensors are there. So these are all examples for sensors. What is an actuator? An actuator is a component of machine that is responsible for moving or controlling a mechanism or system. See, in our the case, if you see our video, then there is a relay connected to the light also. So you can see here in the video also. So that relay is called actuator. So it will switch on or switch off. It will do some mechanical operation. So then what it requires, a control signal is required and a source of energy. So if you see the our video, you can see the Raspberry Pi. I will just see. You can see here the. I don't know whether I can move this to. How to move this video? So video is visible to everyone, right? So here you can see the Raspberry Pi, and then light is connected. There is one relay here. So what you can do? See what I'll do. Since I could not move the screen, what I'll do, I'll just this video way to move. The screen, overall screen we can move. Overall screen I can move. See here this video, you can see this is the relay. How to maximize this you have to see now. So video. So video has some issue. Okay, then we'll see later. How to move this video? That's what I would understand. Where it where it went, I don't know. Okay, leave it. So the actuator is a relay which we can use it for the controlling the lights and yeah, this video is there, but how to maximize, any idea? This video how to maximize? Any idea? Can somebody help to maximize this video? Any layout settings, anything is this?
No, sir. The participant have to pin that. There will be a pin symbol. So if you are clicking that pin symbol means which is going to maximize.
Okay, I want to maximize from my side. Here I want to maximize. In this screen, I want to maximize. So this we have to explore something. We have to do this. So now it is small screen. I want to maximize and see. So any settings are there related to this? So video. This is the one. Send resolution
So
maximum.
you just start presenting now in this screen and then choose that one. Sir.
Okay, presenting now in this screen and then choose this one.
Yeah.
Presenting and choose. Should come. Okay, the present now. I have to remove the presentation then.
Yes, sir.
Okay. Yeah, now it is visible to everyone in a big screen. So you can see here under the light you can see this is the relay actually. This is the relay. The blue color one is the relay. This is actuator basically. So then present now the entire screen. Okay. So we have to explore some more how to use this video. So then how it works, when the control signal is received, the actuator responds by converting the energy into mechanical motion. So it will switch on and switch off the whatever, no, the lights or fan, something. So the wireless networks are like, we have different wireless networks. So here we have Zigbee. Zigbee is mostly used in the case of IoT. Then we have the Bluetooth, and then the Bluetooth 1 and 2. Then we have the Wi-Fi 802.11b, 802.11a. These are all Wi-Fi LAN connections. So this is the 11G is our Wi-Fi connection. Then 11B also there. So the range and short. This is for short range. This is the long range. This is used for long range. This is for short range. So private area network also there. That is Bluetooth and all used for private area network. So the application layer protocol, that is message queue telemetry transport. You can see here. See, for mobile users, I will just enlarge the screen. So here we have the topics. For message queue, you have the topics actually. So the different topics are added here. Then the different the nodes are there. For example, node 1, node 2, like that, different nodes are there. Each node is trying to publish a topic. These topics are in the queue, in the server or broker. Then some users are subscribing to these topics. So for example, topic 1, who is subscribing to topic 1, even though the many topics are coming to the queue, only topic 1 will go to the subscriber 1. And if subscriber 2 is, if he's subscribing to topic 2, the topic 2 will go to subscriber 2 only. So this is the overall the setup for message queue telemetry transfer, that is MQTT. This is pops up concept. So this is widely used in the IoT setup. Same way, this you can see, this one you can see. It is exactly same as MQTT. Only the difference is different queues are maintained for the different subscribers. For example, in topic 1 only, many messages are there. All are in queue. Same way, topic 2 another queue, topic 3 another queue. So that is the only change in the advanced message queue protocol, AMQP. That is the only change. Then constrained application protocol. So here also almost pops up concept only. You can see here there is a REST COAP proxy is there. So this is the internet from the REST. It uses the REST REST protocol. So here you see COAP environment, COAP server also there. So many users are connected to the server. So almost same concept only, COAP communication and HTTP. So from the internet, HTTP communication is happening through TCP IP. So here you can see REST protocol or REST messages are coming here, and then it is distributed to the server, and then from server it is distributed to the different clients. So this is the difference between MQTT and then COAP. COAP involves two different protocol like HTTP protocol and then COAP communication protocol. So it has its own communication. It's not MQTT. So MQTT is having its own protocol. The next one is extensible messaging and presence protocol. It is similar to COAP. Here you can see the internet, from the internet, the gateway is used for here HTTP protocol or XMPP is used here. Then here you can see the XMPP, extensible messaging and presence protocol is used inside. Once it reaches the server, the XMPP is used to connect to both gateway and server. Then from server to each client also connected with XMPP. So this is a specific protocol. It's similar to MQTT, but it's slightly different than MQTT. Now Raspberry Pi will have a small look. So Raspberry Pi is what actually? University of Cambridge Computer Laboratory, they made this. The skill level, we don't require a big skill level like how electronic students are having so much knowledge. We need not have that much, but a credit card sized PC only plugs into TV or monitor, inexpensive, have $35 something like that. Capability is programming, electronic projects, office, and play high-speed videos. So here you can see the have different components. We'll see in the next subsequent slide. So what are the components are there? See 5-volt micro USB connector. This is where you have to connect the externally. You have to connect the wire to the plug point where you will get the power supply here. Then similar to the one on a lot of mobile phone. So like mobile phone charger also you can use here. Then micro USB you can use. Then you can see the different things like audio video also there. For example, here HDMI cable you can use. So if you see my video, you can see all the connections. It's observable. So here HDMI connection is made in my case. So then you can see the HDMI audio video works with modern TV, and so I connected to the TV. This HDMI cable I connected to the TV also. So then there is something called the RCA video works with most older TV. This is for connecting to the TV. Then audio standard headphone socket, so you can use a headphone to listen the music and all. Then it is a two USB ports are there. You can connect. Actually in my model B, I have four USB ports. Then GPIO general purpose connector also there. So I used to port 17. So I used port 17 here. So then I used 100 MB Ethernet. Ethernet I not connected, but Wi-Fi I have connected. Then system on a chip. This is the most important part. The Broadcom chip is used 700 MHz CPU speed. Then LAN controller also there. Camera interface also there. You can connect the camera also. Then DSI display interface also there. Then SD card sockets are the 32 GB SD card you can insert so that you can store all the data in the 32 GB the SD card. So these are all the important components of our Raspberry Pi. Now yesterday we left some tutorial in between because see what happened yesterday. The one small mistake happened. The tutorial 3, when I connected with the mist, it was not connecting. I told yesterday I told you tomorrow I'll show like that. I told. So that I am going to repeat. But unfortunately, what happens? This you have to repeat the experiment 1, 2 also to see the experiment 3. Because experiment 3 you cannot directly use, but experiment 1 and 2 also you have to use. See here what is the problem. So what is the mistake we did? I will tell you. So the mistake what happened here is so I executed this init command. The init command I have to execute with I have to delete this data folder. Then I have to execute. So that I missed. So what I'll do, today I'll do the same. I will delete and then I'll start. So what I'll do here, I think everyone got this tutorial. You can also try if you want parallelly. So if you have laptop, so mobile users also can do this. Okay. So what I'm doing here is I'm going to delete this folder, already existing folder. I'll delete this folder. Now I'll do this. Okay. Now I'll open one admin with admin privilege. I'll open a command. So I'm opening a command prompt with admin privilege. So here we'll execute now. So I have the get already in my laptop. So I'll move to this folder first. Get. I'll keep this side. Very easy for me. Then so I'm in this folder. I will open. Now I'll new account I'll create with the new folder also. That folder I deleted. So new account I'm going to create. Okay. So I have to enter the password. Blockchain I will enter. So when you do the real network, don't disclose your password. So this is the address. I'll note down this. Then what we'll do? We'll create a custom Genesis block. So I'll go to the get folder. Then there is a folder I have to create. Now you can see here. So this one custom. Now we'll see here get folder. See get program files. Get. So custom Genesis. So this address I'll add there. Whatever I copied now. So this was a previous one. I'll remove this. So this is what I told you when I was showing the slide. I told you about the difficulty level. See, the difficulty level is 400 as of now. But when more and more miners are joining your network, then you can increase the difficulty level. So now this is the custom Genesis JSON. So what we'll do, we will run the init. Now we'll do the init because this folder I deleted. So this is the init I'm going to try now. So you have to observe the successfully wrote Genesis state. This you have to observe. This is a successfully done this step. Then you have to observe this successfully wrote Genesis state. Now what we'll do? We will run the blockchain now. So here, not this. See, this is the command to run the blockchain. Here, get is the application, what Ethereum application. Data directory is Ethereum private to tutorial chain. Then slash dash RPC, that is no, the remote protocol no, we are defining here. So then RPC CORS domain also. So here you can see here RPS CORS domain also there. Then there is a local host 3000. So we are giving the CORS. No, CORS is what? So we are allowing this port to do the expose. Then RPC port is 8545. Then RPC API, what protocols we are going to use. This is the port we are opening. And then RPC API is the database, net and admin, Web3, ETIs, personal, SSH, minor. These many protocols we are allowing. Then node discover. Node discover means it will not find its own the peer, but we have to explicitly tell this is the peer. Verbosity is 6, then max peers to the network ID is 124, then IPC disabled, then port 30305 is the one we are exposing this. No, the accounts will be transferring with this port only. So what we will do now? We will execute this. Yeah. Now you see the blockchain is running now. The blockchain is running now. So this is the first exercise. I will go to the second exercise now. So here in the second exercise, we are going to attach a terminal with this to communicate with this blockchain. So for that again I have to open command prompt with admin privilege. So here then you can see here I'm going to attach this command window with the blockchain. So once it is attached, now if you see the ETH mining, ETH.mining if you type, to give the status as false. Now I'm going to start the mining work, miner.start. So now again I will try the ETH mining. This time you see that it's true. So now the mining work is started. Now I'll move to the exercise 3. This time exercise 3 should work. Here what we are doing, the Ethereum wallet Ethereum wallet we are going to use now. So I will open one more window with admin privilege. Okay, so here what we'll do, I will move to the Ethereum wallet folder. In the Ethereum wallet folder, I will run the command with the same port, whatever we expose. Same port 8545. I'm going to attach application which can transfer the transfer the ether between. So now one more, this window will come. You give OK. You have to wait for some time to the client to open. So missed client is we are going to use to transfer the ether between the accounts. So one more window comes like this. So what you do, you have to close this, not required. Then one more window also there, like this. So you have to click on launch application. So when you click on launch application, So now already see 199 ethers are there. So here you can see now 0 ether is displayed. 0 ether. Again some problem is there. Yesterday I tried, it was working fine. Again some problems are there. 0 ether is coming. Main account is having 0 ether. Cannot retrieve ENS addresses unless fully synced on main chain. Fully synced on main chain. Mining is this. So again 0 ether is coming. 0 ether means you cannot send any. You can't send actually. Ether base. Ether base is AB. AB38. So this is what we used to. So ether base is coming like this. Then fully synced. ETH mining miner start. So again today also same problem coming back. So I deleted all the folder, everything I done. But still this problem is good. Yesterday it was working fine. So it was showing either 199 earlier. So waiting for blocks. Some error like cannot retrieve ENS address unless fully. Okay, anyway, I will let you know about this problem. So again, the same problem came yesterday, whatever done. But yesterday evening when I tried, it was working fine. Again, this problem coming. Well, I don't know the reason. So here minus start we done. ETH block number also we can check. Any block is added or not. The ETH get balance Coinbase. Zero only. So something wrong. Get that okay. Here blockchain we created. So data directory created or not? Just will check. Created data directory created. Get is there. Then tutorials in RPC local 3008 minor discover no discovery all those things are there. Okay, anyway the okay I will show from the Google Cloud platform only. This is giving another problem. So I'll try to fix. I'll let you know what is the issue. So I'll go to GCP console now. We'll open the GCP miners. I'll show demo from there. So this is my GCP console. Here we can see the virtual machines. So if we go to the compute engine, then VM instances. So initially you can take it the free credit. So you will get around 20,000 rupees and then 59 days remaining. So another 2 months I can use. So here you can see here the two virtual machines are created. So I will open the window. Then two window I will open. The one I will attach and one I will have the miner to run. Same way the second virtual machine also I will open the miner and one window for attaching the miner. So this is the miner window and this is the attachment with this. Then this is the miner 2 window and this is the attachment for this. So these two instance one is one my virtual machine. Instance 2 is another virtual machine. So two virtual machines we are using. So let me start the minor in the minor one. See here, first I have to go to the folder. So this is the folder home Digitron Solution 7. RPI is the folder. I'm going there. Same way here also. Then for minor 2, another folder is there. So here also Digitron Solution 7 RPI. Here also the attachment is there. So then now what I have to do? I have to start minor 1 and minor 2. So to start minor 1, what I will do? I will use the command sh. So now minor 1 is started. Same way I will start minor 2 also. Here I am going to start minor 2 also. So now what I will do? From the attachment, I will attach now the minor 1 attachment I will do now. See here, get attached localhost 8042. So it will attach. Now it is attached now. So here some commands you can try like minor, um, some of the commands like what you can try is ETH mining. ETH mining you can try whether it is mining or not. See now it is mining already because what? Why it is not doing this? So we already enabled the mining, so that is why it is giving true. But anyway, we can start explicitly also. So what I'll do, I will start explicitly minor dot start. See, I'm giving minor dot start now. See now, it is mining is started. Same way, here minor dot start, minor dot start. Now you can see here I not yet attached. 1 minute, sorry for that. I'll come out of this. I have to attach first, then I have to start the minor. See here, in this case, localhost get s attached. So now I attach. Now I can start the minor. Minor dot start. Minor dot start. See now it is started. Minor is started. Here you can see the mining work started in the minor 2 also. Now we have to see the Raspberry Pi. Raspberry Pi 1 minute. I'll try. See the I in my second screen it is the Raspberry Pi is booting now. But how to display this? 1 minute. I will try to move my camera. In the second screen now the Raspberry Pi is booting. You can see here. it takes little more time, the Raspberry Pi. So now the Raspberry Pi window appears. What I'll do, I'll take the keyboard for this and then I will try to. So here Ubuntu, then password for this. So now Raspberry Pi is booted. You can see in the video, I could not share the screen actually. The screen is shared with the other one, the whatever minor one and minor two. But Raspberry Pi you have to see in the video only. And it is appearing, is it correctly appearing for you? So video is current, I think correctly appearing for you. Yeah, then I'll go to terminal. I'm opening a terminal. So here we have to start now. The Now we have to start the Raspberry Pi. Here also we have to start the mine. We need not do the mining work, but we have to start the Raspberry Pi. So for starting the Raspberry Pi, what we have to do is we have to uh, so so here you can see the directory structure ls if you do. So rpi gcp is there, rpi iot is there. So 1 minute, I'll just I want to show you the pairing. Just we'll close there only. Pairing, after showing the pairing, we can close the session. So cd home ubuntu rpi gcp. Okay, rpi gcp you have to go. So cd, so ls, so cd slash home, so cd rpi gcp, rpi. So the folder is rpi rpi gcp, cd rpi gcp, rpi gcp. So here if you see ls, if you type, you will get the genesis, all are there. So all one node also added already. So what we can do here, here we can start the blockchain here. So to start the blockchain, what we have to do now? To start the blockchain, let us do let me open the one file here. See, go to this one file I'll open. So here I have the blockchain. To open the blockchain, just I have to connect, I have to copy this and then paste it here. Yeah, now the blockchain is started in this window. What I'll do, I'll open one more window, then I will attach. Here also it attach. So in the video, is it visible for you? Okay, I will attach now. I will attach now. Now we'll see the peer-to-peer network and then we'll close the session. So here we'll paste it. Then, so it is attached now. Now you can see. Now, see all three. So here minor we need not start, but we can see here admin.peer we can put admin.ps. So it's not coming. We'll go back to the other one, minors. So other minors like minor 1 and 2 are there. This is a minor 1. Then minor 2 attachment. So here also we can try admin dot yes. So the peers are not connected. So the reason we would find the admin dot node info admin dot node info. So we'll copy paste better. So here we can copy paste and see the node information. So if you see the block number, I think it takes some time to sync up. Here block number 1411. Then here we'll see the block number. So this is another minor 2. In minor 2 I have attachment. This is another minor attachment. So here we'll see ETH block number 6652. So it takes some more time to sync up. So both the block number has to be same. Then it will display the PS admin.ps. Till that time the sync up is going on. Since we started minor now only, so it takes some time to sync up. So as of now, what we can do is with this setup, since minor, so admin.peer, so when we type admin.peers, it has to display the other node. Then only we can proceed for any transaction. Now it is empty string it is showing. So here also we'll type and see admin.ps. So admin.ps, sorry, admin.ps, admin.ps, admin.ps. Yeah, now it's coming. admin.ps. So it is showing the other one, like the minor one, it is synced already. So here we'll see now admin.ps. See now it is these two minors are synced now. These two minors synced now. That is one good thing happened. Now we have to sync up with the R file. See now the because of this synced up, we can send the no the ether from one node to another node. So that I can show you. See, since it is synced up, these two miners are synced up. Now what we can do is some ether we can send from miner 1 to miner 2. That is possible. That will try just at least one transaction will try. So from ET guys, send transaction from ether node 1 0 to ether node 1, value of 10 ether. I'll try this 1 minute. See here what I'm trying to do is from ether node 1, miner 1 to miner 2, I'm sending some ether. We'll see whether it is working or not. Yeah, some transaction ID has come. Now you have to cross check whether it is sent already or not. See here what we can do is ETH pending transaction if you type, any pending transaction is there or not. So the pending transaction, whatever we send now, it is pending only. So how to confirm this? Suppose if we go there, Web3 from does account one any credit is there or not? Just if you see 10 is there, that means 10 already sent. But whatever now we send or earlier one we sent, that is what we don't know. So we could have checked first itself. Anyway, we'll try one more transaction. Now it is 10 now. So one more 10 if we send, should become 20 now. We'll see that is happening or not. 10 only. So miner will take some time. So this transaction, now it is 20. So, so is it visible for mobile users? So it's 20 now. Earlier it was 10. Now you can see it is 20. So now two miners are synced up. Two miners are synced up. Only Raspberry Pi is not synced up. So what is the problem with the Raspberry Pi? That is what we have to check now. Why Raspberry Pi not synced up? That is what we have to check now. Once. So how long we have time? See already 12:15. So madam, can we stop here or what is your opinion, madam? Hello?
Sir, if it is okay for you, let me start, sir, because already few participants were left from the session. So
So
we can
madam,
stop here itself.
I think we can
If
stop here
want,
because I showed the peering also, the peer-to-peer network also I demonstrated.
but
So
it is fun
transaction
and
is
informative only, sir. We do so. Other participants are interested means we can continue, sir. I'll just ask to them by using chat box. Few minutes I will get you back, sir.
yeah, better if all are leaving, then we can close it actually.
Okay, sir. Otherwise we will close it now.
Yes, madam. We'll close here only because some more steps are there, but it consumes time actually. Another minimum minimum I need 15 half an hour I need. So better we close
Okay.
here. Maybe next session
Yes,
anyway next
sir.
week
Next
we
session
have
will be at
we'll,
2 p.m.
we'll
It is
continue.
going to
Next
be
one also
started.
we have now, madam. The one more FTP is there. So I think we can have the continuity there only. Yeah.
Okay.
Okay, madam. Thank you very much. Okay, bye.
Thank you, sir. And we
Yeah.
are really thankful to you. And we had a wonderful session for yesterday afternoon and today morning also. And
Yeah.
we could get knowledge about peer-to-peer network also. You are not just stick on to your topic alone. You had given more knowledge about peer-to-peer network, centralized and distributed network, even smart contract, everything we had came to know that we could got a clear picture on these topics along with blockchain and IoT. Really, we are very happy to have you as a resource person, sir. Thank you very much.